What is the additive inverse of the expression a minus b? Don't forget, guys, additive inverse. So for example, let's go back to the basics. If you had 3 plus what gives you 0, it would be 3 plus negative 3. So really you're negating the 3 to a negative 3. If it started with negative 3, go to a positive 3. So if they're giving you a minus b, that means you have to negate the whole thing. And this one's a little bit tricky because it's not a monomial, it's a binomial. So really you're negating both, which means that the a is going to go negative because it was positive, and the b is going to go positive because it was negative. Therefore, it's negative a plus b, which is tricky, so be careful with that. Zero and negative exponents. We're starting chapter 7, 7-1. This is a little bit blurry because I enlarged it so much. One of the things you guys want to remember is anything to the 0 power is 1. So no matter what it is, anything to the 0 power is 1. Even if they give you something tricky like this, which I've seen on a state exam before, negative 4 times 2 divided by 5 squared plus 7 to the 4th, and then they raise the whole thing to the 0 power. No matter what is inside, if the whole thing's raised to the 0 power, the answer is 1. 2 to the first power would be 2. 2 to the second power is 2 times 2, which is 4. 2 to the third power is 2 times 2 times 2, which is 8. 2 to the fourth power is 2 times 2 times 2 times 2, which is 16. If you go the other way on this, where the exponents now become negative, if you look at 2 to the first power, it's 1/2, whereas 2 to the negative first power is 1/2. Okay, so you don't have to write all these down, but we're going to actually go through on how to deal with negative exponents is what we're actually going to tackle today. Major concepts. 0 as an exponent. Anything to the 0 power is 1. So they're showing you examples. 4 to the 0 is 1. Negative 3 to the 0 is 1. Notice this right here. If this said negative 3 to the 0, now the 0 power only belongs to the 3. So 3 to the 0 is 1, and then that negative will follow over. So be careful when they put parentheses around it, it changes the answer. 5.14 to the 0 is equal to 1. If you have a negative exponent, you have to do the reciprocal. So really you think about it like it's 7 over 1. In order to turn a negative exponent into a positive, you flip it. So it would be 1 over, and as soon as you flip it, your negative exponent goes to a positive. So it would be 1 over 7 to the third. Then of course you would figure that out. We have negative 5 to the negative 2. If you put that over a 1, you turn this negative 2 into a positive by flipping. So instead of negative 5 over 1, it would be 1 over negative 5. And as soon as you flip or reciprocate, you're talking a negative exponent going to a positive. So that is this property right there. Let's look at some examples. What is a simplified form of each expression? 4 to the negative third. So put a 1 under it. Not that you have to, but it might make it easier for yourself. Because you see the negative exponent and it applies to the 4, you're going to reciprocate, which I don't think that's a word, but I use it all the time. You're going to say 1 over 4. So as soon as you flip it, the negative 3 goes to a positive, which is going to be 1 over, and then this is where you're going to need your calculator because you're going to have to do 4 times 4 times 4 3 times, and you end up with 1 over 64. Example B, anything to the 0 power, the negative is included because of the parentheses, is 1. 3 to the negative 2, put a 1 under it, flip it, and it turns it into a positive exponent, you end up with 1 over 9. 6 to the negative 1, if you flip it, it will make it a positive, and 6 to the first is 6, so 1/6. This one is negative 4 to the negative 2. If you flip it, don't forget to leave the parentheses around it because you're squaring the negative. If you take the parentheses off, then it says you're only squaring the 4. So you end up with 1 over negative 4 times negative 4 is 16. So 1/16. Okay, let's see if we can do some of these. What I'd like you guys to do is put me on pause, try one, and then continue on and see if you get them right. There are, as you notice, some blank outs here. I will fill them in as we go. I'll just make those up as we go to get examples going. So in this one, you have a variable. It's the same property. You're going to flip it, 1 over x. As soon as you flip it, it turns the negative into a positive. Even if you flip it from the denominator back up, like for example in b, let's say it was a negative, I'll make that a 2. Because the negative's in the denominator, it still follows the same property. So now you're still going to flip it, which means it's 1 over positive n to the positive 2 over 1, because I flipped it, and it changed the negative to a positive, and n squared divided by 1 is n squared. Okay, go ahead and try this one, and then take me off pause. I'm going to put a 1 under this. Understand that the negative 3 only belongs to the c. Very important to understand that. This is where kids mess up all the time. So the 4 to the first power, imaginary 1, does not have a negative exponent on it, so you do not flip it. The b has a positive 1 on it, which means you do not flip it. The only ones you're flipping are the ones that have negative exponents, and that one is only the c to the negative third. So c, out of these 4 numbers in here, is the only one that gets flipped. Some kids make the mistake and flip the whole term. Let's make this one a negative 3. So go ahead and try that one. Okay, be careful. The 2 has a positive first power, so you do not you leave the 2 alone. Nothing gets flipped. So it stays in the numerator. The a to the negative 3 is a negative exponent, so you have to get rid of the negative exponent and flip it so it goes from the denominator up into the numerator and turns into a positive, which means actually 1 is left in the denominator and you don't write that. The trick to remember, guys, is that you can never leave, or they say we should never leave, a negative exponent in the denominator. All right, let's look at this one. N to the negative 5 over m to the 8th. I'm going to draw my fraction bar, and I'm only going to flip the ones that have negative exponents. So I'm looking at m to the 8th. It does not have a negative exponent, so leave it alone. Look at n to the negative 5. It's in the numerator, and it does have a negative. So flip it, and it goes positive. And what's left up here? A 1. And the second set of problems, they're telling us that n is equal to negative 2 and w is equal to 5. So we're going to have to substitute. You can either substitute first and then flip the negative exponents, or you can flip the negative exponents and then substitute. Really your choice. I'm going to go ahead and flip them first. So the negative 4, the end of the negative 4 is got the negative exponent. So flip it and it goes to a positive 4. The w to the 0, remember anything to the 0 power is just 1. So now I'm going to go ahead and substitute in n, which is negative 2, to the 4th power, which is going to end up being negative 2 times negative 2 is 4, times negative 2 is negative 8, and negative 8 times negative 2 is positive 16. Look at the next one. Let's go ahead and get rid of our negative exponents. The w squared is still positive, so leave it alone. The negative 1, n, is negative, so we've got to flip it, and it goes to a 1 down here, and 1's left on the top. Now let's go ahead and substitute. W is equal to 5. Whenever you substitute, try to remember to put it in parentheses. It will save you some grief of mistakes. -2 to the first power. So we end up with 1 over 5 squared is 25, and 25, -1 to the first power, or excuse me, -2 to the first power is -2. We end up with 1 over -50. Make sure you guys are putting me on pause and trying these before I go through them. Otherwise, you're not helping yourself as much as you could. N to the 0, that equals 1. W to the 6, it's not negative, so nothing gets flipped. So we end up with 1 over 5 to the 6. So that's 1 over 5 to the 6th power. You have to multiply 5 times 5 times 5 times 5. Oh, lost track here. $15,000, hopefully I did that right, 625. Okay, look at the last one. We have 1 over n, which is -2, times w. Whoops, look at that. I'm going to erase that and follow along what I was doing before, which means I'm going to flip. So I've drawn my fraction bar, 1's going to stay there. N is to the first power, so that doesn't move because it's positive. And w is a negative, so you have to reciprocate, and it turns to a positive. So we end up with 5 over -2. And that's it. You can leave it as an improper fraction. Alright, let's try a few of these. 2 to the -5th. Try these on your own and then have me come back and follow through to see if you got them. This is going to be 1 over 2 to the +5th. Don't forget that's 2 times 2 times 2 times 2 times 2. So we've got 16 times 2, which is 32. Anything to the 0 power is 1. This is going to be the only ones you move. The 5 is to the first power, so that stays. S squared is positive, so that stays. And t to the -1 is positive, and you don't have to write the 1. As a matter of fact, they don't want you to. So the only variable that moved, or number that moved, is the t. And number 4, the only variable or number that has a negative exponent is the x. So 4 is to the first power, that's a positive exponent, leave it alone. And the x to the -3 is going to go positive, which means I no longer need my fraction bar over my 1. And I'm done. In the second set, this is evaluation. So let's first rewrite it getting rid of negative exponents. Not that you have to do it in that order. The only one that moves is the b to the first. I'm going to leave my imaginary 1 there. A is 2, and b is -4. So 2 times 2 times 2 is 8, and 8 divided by -4 is -2. Go ahead and try this one. We get fraction bar. I'm going to do it over here. The 2 is to the first, so that stays. The -4 on the A drops and goes positive. And the b to the 0 is just 1, so you actually don't need that. Substituting in my A, which is 2, that'd be 2 to the 4th. 2 divided by 16, which simplifies to 1 over 8. And there is